So I'm going to do a little follow-up video on this Miniware power supply. My previous video was really popular, it's had loads and loads of views, it's been really good. If you haven't seen that yet, then go and check out the link down below, or maybe I'll link it up at top here or something like that. But what I had some comments on about is checking things like the transient responses and like turn on, overshoot and things like that. So I'm going to do a little bit of testing on that. It's going to be a short video and we'll just go through and check a couple of things which I didn't cover in the previous video, and hopefully it will cover some of those questions. Just turn the thing on. Yes, it does still work after the last incident. So I've got this hooked up to my oscilloscope. I've got these cables coming out the side here. I've got, let's see, these ones are going to my DC electronic load. These two are going to my Siglent multimeter. These two are going to my oscilloscope, so we can look at the noise on the scope. Now the problem is my place here has got a lot of noise. I've got a lot of electrical noise in this area, and it's a real problem for trying to do small measurements, especially on my LED lighting being on. I'm getting huge amounts of noise on the scope. So what I'm going to show you looks awful, but it isn't from this. I'll show you now. So here you go, here's the noise right now. It's actually going off scale and everything. That's at 10 millivolts per division. No, that's at 20 millivolts per division. So all that noise, most of that is from my LED lighting. If I actually turn off the power supply, it doesn't change. Right, so that turn off the power supply. If I actually enable the output of the power supply, didn't change. And basically what I'm trying to show you here is that yes, there's lots of noise, but it is not the power supply which is generating this noise. I've got so much other noise around here that the noise from this power supply is immeasurable. I've got 20 megahertz bandwidth limit set to it, and times 1. If I do 50 ohm loading, that helps get some of it down. But all this noise here, that is my LED lighting. So I actually can't really do much better. If I turn some of these lights off, it might get slightly better. Maybe it'll do it. There we go. See, it changed a bit by turning some of my lights off then. The noise from this thing is immeasurable. I can't measure it. Right, so I've now got this set on DC coupling, 1 volt per division, in order to get it on the screen a bit better. The power supply is currently turned on. Let's turn on the load at 5 amps and we'll just see what happens to the DC on here. Nothing. Okay, so let's turn off the supply output, and what we'll do is we'll do a single trigger. And we'll catch it where it turns on, right? And we'll see if we get a spike or something like that. Ready? Turn it on. There we go. There's a trigger point over here. It's a really nice little ramp just there. That's nice. Let's bring it over. So 200 microseconds per division, look at that, there's no overshoot whatsoever. And that's with no loading, so that's looking fine. So I've got a 1 amp current set on this now to try and put some stress on it as it turns on. It does seem that when it's got a load on it, when it first turns on, it actually collapses. It's like it triggers the current limit. Even though the current limit is set at 10 amps right now. So let's try this now. Yep, that did it that time. There we go. And it's a nice sharp edge, look at that. That's with 1 amp loading on it when it turns on. No worries whatsoever. And that is the drop off. So I've got 1 amp loading on it still, and when I turn off the power supply, that is the down ramp. No issues there at all. There's no signs of any problems. Zoom a bit more. See, completely normal ramp. It's fine. So now I'm going to do some more tests. When I did the other video, there was voltage sag evidence on here, right? So what voltage you got when it's under heavy load, the voltage is dropping more and more. And I speculated at the time that it's probably these cables. I've now got my Siglent multimeter hooked up over here, which is directly on the output of the power supply, which will prove what the power supply is actually outputting. That eliminates these cables as a potential source of error. It's something I probably should have done in the last video. So let's power this on and actually see what's going on. So enable the output. Still just doing 4 volts because it's convenient voltage. And hopefully you can see the displays here. It says 3.997. You have 4.000 there. And it's just showing 50 millivolts down because it's got a 1 amp load on it. So let's increase the loading. Let's go, say, 4 amps. Decent load. I'll do it properly. So you go, it's got 4 amps on there now. So you can see this is still saying basically 3.99, 4 volts, it's set to 4 volts. We're getting 4.003 here, so that's still showing the output as being good, and we're getting sag here of 200 millivolts. So that just sort of shows that the sag I was getting in the previous test isn't output from the power supply which is sagging, it's these cables causing voltage drop, which is as I speculated. So let's increase the loading some more. Let's do 7 milliamps, let's do 7 amps. Again, we've got a quite big drop here, 250 milliamps or so, but the actual output of the power supply is still at exactly 4 volts. No worries at all. Let's do 9 amps. So at 9 amps we are getting some collapsing. That's likely because of my actual power supply which is powering this brick. So the brick power supply is probably what's causing the problem there. Yeah, so that's handling okay. So that's 25 watts. It's probably my brick power supply which is causing problems because I'm still using this brick to power it, right? So it's limited by this. But I should be able to do like 100 watts or something, or 50 watts or something I think it's rated for, but yeah, it could even be the cable here. This cable, actually this cable's slightly warm, so it's probably this cable which is causing the problem. It's causing voltage drop. So there is actually a way of seeing the input voltages and stuff on the menu here. So input voltage, yeah, there we go, input voltage is sitting at 11.48 volts there. If I change this to say 5 amps, there you go, it's 20 volts. So this goes to prove that the issue isn't this power supply is causing that to drop off, it's probably this cable or this brick. Most likely this cable. It's actually feeling a bit warm actually, yeah, the cable's a bit warm, so I think I'm overloading this supply, so that's why it's dropping off. But you can see the voltage is really good, no problems at all. It's really nice having that option there to check the input supply. That's a really good feature, I like that. So the other thing that got said in the previous videos comments are things like it's not actually a power supply, it's just a glorified buck converter and stuff like that, or buck boost converter. I disagree. A power supply, I think by definition, is something which converts power from one form to another. So if you have a fixed voltage coming in and this is converting the voltages and converting the currents, I think it's a power supply. Because it's also in a controlled way. You can set the voltage, you can set the current. To me, that is a definition of power supply. If you had a mains power supply, like a linear power supply over here, that's got 240 volts fixed voltage coming in. You're changing the controls on the front panel to change the voltage and the current. That is called a power supply. I believe this is truly called a power supply, not just some glorified buck converter, you know, as some people are basically putting it. I think a power supply is a correct definition and a correct classification of this unit. It is a power supply. Fixed voltage in, variable voltage out. It's a power supply. Don't forget to click like, give us a thumbs up before you go, and subscribe if you've not been here before. Catch you later. Bye.